Hi guys, and welcome to this second follow-up video for the Bluetooth module video. So for a quick recap, in the first video I showed how to build and program one of these, which is an HC06 Bluetooth module. This in particular is the ZS040, which I have a link for in the original video, so you can get the exact same one, you know it programs, right? And in that video we added two connectors, one for using in your R9 or a standard smart port plug, so it's wired like a normal servo. So if, for example, on the bottom of your Taranis X Lite, I believe there's an S port plug on that, and that's wired up like a normal servo. So power in the middle, ground on the outside, signal on the other side. You can use that in there. We also added another plug for a JR bay because they're wired slightly differently. You can see the positive and negative are reversed. So that was the first video. The second video, I showed how to get it working in the JR bay, which is the bay behind this R9M module. But there's another bay or another connector we can use. This one right here is an internal UART in the Taranis itself. So in this video, we'll be looking at how to use this one. Now I'm going to let you know in advance, I'm not actually going to do any major builds or anything. I'm just going to make an adapter cable so it can plug in there and just hang out the back for the time being. I may do another video because I'm thinking about putting it internally, but there may be an extra video, right? The reason I got these Bluetooth modules in the first place was for the U360 GTS antenna tracker, and I've now read that they actually use a Wi-Fi module now, which is very similar to the HC06, and the way you code it and put it in everything is very, very similar. So I'll be looking into that, and I may install the Bluetooth on one side so I can connect to an app on the Android tablet, and then the other side have the Wi-Fi module to connect to the antenna tracker. And somewhere I'll put a switch for off Bluetooth or Wi-Fi so we can pick and choose what we want, and it will all be running off of this single UART in the back and all neatly inside the Taranis. But anyway, let's go in and explain a bit more about this this connector here. So this is the back of my Taranis, and it's pretty easy to wire up. This is all you need. So you've got the ground here. This second pin in is the power, and the third pin is the TX. We don't need to worry about the RX because we're only sending data out to the Bluetooth module or out to the Wi-Fi module, whichever we're using. So we don't need to worry about the RX. So you might think, oh, that's easy. I can just plug it straight in with the JR connector, which the pitch might actually be the same. I've not tried it, but you can't. This V main here is outputting full power from whatever battery you've got inside, and where these little Bluetooth modules are running on, well, this one here is 3.6 to 6 volts, so ideally around 5 volts we run them on. Well, this is 9.9 volt cell, and that's, you know, nominal voltage, so fully charged they're 10 point something volts. That will just fry the Bluetooth module. So yeah, what I'll be doing is making up a small loom. So the cable's coming out. These two will go to the voltage regulator, and this one will carry on to a servo plug. And then the other side of the servo plug plugs into the loom that we already have on the Bluetooth module. So the inverter's already there. If you're doing this straight to the Bluetooth module, you'll need to do the inverter side still. Okay, so we're back on the desk, and I've taken the battery out because I want to talk about the connectors. So this one on this side, I believe, is actually the same size as a regular balance connector for a 2S battery. This side, it's not quite the same. It's a similar series of plug, so they're JST still, but this is a PH model with a 2mm spacing. So what you want is one of these. So that will go straight into that plug, no problem at all. I'm not going to put it in because I've had it in and they're a little bit of a pain in the ass to get out, but it does fit. So that is, once again, a JST PH with 2mm spacing. But as you can see, it looks, it will focus. There we go. It looks very similar to a balance plug, but the hole spacing is different. So anyway, if we I've lost my diagram. So what we're looking at here is the ground and the power are actually in the right places, so that's helpful. And then we have the white, which is the transmitter for our UART. So what I'll do is I'll whip that pin out, and then we know what we're up against. So yeah, I've actually got that's a balance there. So yeah, the power is a 2S balance, but that there is a 4 cable balance lead, and you can see the difference. There's quite a big difference in size, but they're very similar series of plug. So we have our lead. And now what we need to do is set up our wiring. So we can't really just go straight into there. So what I'll have is we have our servo that will join in together like that. And ideally we just want that into there. But what we have to do first is use one of these. So this, as you can see, it's having trouble focusing. There we go. But it's a really small voltage regulator. They're reasonably noisy, so they're not great for using on FPV. As you can see, it's made by Maytech, and it will take 7 to 21 volts on the input, and then 5 or 12 volts out on the output. It's by default it's 5 volts. If you bridge these 2 points here, it's 12 volts. But it is stepped down, so it has to be, the voltage that you put in has to be above the voltage that you want to get out. So we'll be putting one of these in line, and then regardless of if I just choose Bluetooth or use the Wi-Fi, it'll be plenty. These can handle up to 1.5 amps. So there's plenty of power. So just a quick diagram, because I'll do my usual trick and fast forward a lot of this, because at the end of the day it's soldering, we know how to solder. So this is the lead from the Taranis. That was the right way. So they will go into there, into the 7.5 volts in and out, and then the output will go to our servo cable, and the white for the signal will go straight into the servo cable, and that will be our loom made up and done. As I said, the signal inverter is already on here, so we don't need to worry about that. We're just making a step down voltage loom. So right, let's crack on with it. As I say, I'm going to fast forward for it because you guys know how to do this bit. It's easy. Right, so there we have the first step. And get it to focus. So we have the two going in to the voltage in and the ground, and then coming out we have the ground and the voltage out. So what I'm going to do is stick some heat shrink over the top of that. Just make sure that there's nothing contacting between the terminals. They're quite small, but these cables seem fine. So I'll get some heat shrink on and then we'll continue. Right, so we have everything ready, and what I'm going to do is solder it or wire it up in the same way as a standard servo plug, so not the JR bay. So I'll put the power in the middle, ground on the outside. There's two outsides. I've actually put it the wrong side. I was talking to myself like an idiot. All right. The trick with these is they're the same way around when you wire it up. So if the ground is on the right, the ground goes on the right. And then all the magic is done by this little bit of plastic. And what you look for is, I don't know if I'll be able to get it on the camera, but inside you can see that little tab, and that will clip over that piece there. So it means that when they go together, they can only go one way around. So that clicks in, then this will go in that way. So now we have our loom that we can plug in to the battery bay. So let's give it a go. And power. Then what I'm going to do, is try and get this so that we can see everything. So we'll be back in a sec. Right, so we're back on the bench. I've got the Taranis ready, Bluetooth module, battery obviously, and I have my tablet. And we want the telemetry viewer app, which at the moment will come back with nothing. There's nothing connected. I've got my AR wing over there, so that's ready to go. So what I'll try and do is get, if I can get that in shot as well. It's crazy, it's actually showing my location. I guess that's off the tablet. Right, there we go. So we can see the Taranis. You won't see the map because I'm going to blur it out. But yeah, there we go. Taranis Bluetooth module. So if I switch this on, skip all this crap. We don't need to worry about that. I'll turn the LEDs off. So we're connected to the model. You can hear that. So if I go through and go into telemetry, we're getting all our telemetry data. You can see the Bluetooth is actually flashing, even though that's interesting. It must have satellites. Yeah, it's got satellites. Right, so the Bluetooth's flashing, but it's not working yet because we've not set it up. So if I press connect, it might actually connect to this module, but it won't get any telemetry. So if I do that, Taranis Bluetooth, it shouldn't get any telemetry. So yeah, it's connected, but none of this is filled in. So if I disconnect, and what we need to do is set up our Taranis. So it's taken ages to disconnect. But anyway, all right, so we go in here, because you hold down the menu button to get into the main Taranis menu. And then what we're going to do, I think if we hold down page twice, we get to hardware. We press up, we go to the bottom. And then what we want is serial port, which is the internal serial port for the module. That's still flashing. So if you click that, enter.
I'm afraid I can't do that for you.
Siri's a pain in the ass. And what we want is this telemetry mirror. It used to be called Smart Port Mirror or something like that, but this is the latest version of OpenTX, and at the moment it looks like it's called Telemetry Mirror. So we click OK on that, exit out, and then what we should be able to do is if we connect now, hopefully we'll get all our telemetry data. There we go. So let me get that in the correct orientation. What's it? That's better. So we got the amp draw, so how much is taken out of the battery, how many satellites we've got, voltage per cell. We've got that we're in manual mode, that we're disarmed. So if I we've got armed at the bottom. I'm not going to spin the motors. Change the mode, so we're acro, horizon. Cruise won't work, obviously. All right, so if I page through, we have iNav, Lua script telemetry working there, so you can see it's all matching up. But yeah, so that's how you set it up with the UART in the back of the Taranis. I was asked about Jumper T16, and at the moment, from what I've read, it's a no. There is an internal UART, but sorry, I'm just going to disconnect everything because I've remembered something else that we need to try. So there is an internal UART in the Jumper T16, but you can't connect to it and do the telemetry mirroring like you can with this at the moment. There's also there's the radio master, I think it's the TX16S or something like that, which is basically they were in partnership with Jumper. They separated a fair way through the manufacturing or the design, and so it's basically a very similar radio, but I know for a fact that the Radio Master has 2 external UARTs, but again, it depends whether they put the telemetry mirroring in OpenTX, whether it will work or not. But what we're going to do now is another question I was asked. Will it work with Crossfire? So what I'm going to do is I'm going to swap the modules over, get a plane with Crossfire, and I'll be back in a sec. Right, so I've got my F1 wing out, which has got Crossfire. Let's get this switched on. Let's see what happens. There we go. Right, so it might be one's a bit blurry because with the Crossfire thing, it's quite a bit higher off the desk. Right, so if I go into telemetry, we can see pitch and rolls working. It's not actually got satellites at the moment, but the telemetry is working. So I can show you that again. If I go into the actual telemetry screen, you can see it's got RSSI, it's got link quality, it's got which power level it's on, all that sort of good stuff. So if I move it, you'll there you go, you can see the yaw and right. So if I stick this in the window, we might actually get satellites. All right, so that's as good as it's going to get. So if I exit out of this, so the issue that potentially we could have with Crossfire is easier to show you at the page we were just on. So if I go through back to telemetry and scroll down, you see all these, the names of the sensors on this side. And the problem that you have is that the names of them, so we got satellites and GPS now, but the names of them, for some of them, is different to what it is with OpenTX. That's interesting. Got no sats, but we've got GPS coordinates. It's still honing in. So the issue that we might have with this is the names of these variables here are different. It might be that we can connect and it will get some things like RxBat is the same, out is the same for altitude. There's G out for GPS altitude on FrSky. But yeah, so that's what might happen is for some reason the guys at Team Black Sheep decided to give it different variable names or different sensor names. Right, so nothing else has changed other than I've loaded the different model. So if we do a connect, and we'll see what we get. So will it work with Crossfire? So it's connected, but we don't actually have anything. So, well, it's weird actually. It says disconnected at the bottom, but it says disconnect at the top as if it's connected. GPS is flashing differently. So if I disconnect, you see it flashes all the time, like it's waiting to pair. And then as soon as you click that, it says connected at the bottom and the flash changes. So it's paired, but we're getting nothing. We don't have anything for the voltage or satellites or anything like that. So yeah, so we've got 10 satellites on here now, which you can't see. There we go. So we have 10 satellites here, but we have nothing here. That's the problem with Crossfire, is it uses different variables, and I can't actually see anywhere to actually change that in here. So yeah, unfortunately, it looks like it's not going to work with Crossfire. It's obviously the Bluetooth is sending all the telemetry over. As far as I know, it could be that it doesn't understand that it's not smart port, so it says, so I'm not sending that. But either way, it's not working with Crossfire. So sorry to you guys that want to use it with Crossfire, but it doesn't work. R9 is fine. I've not tried it with anything else, but I'd imagine it would be fine because it's all just smart port. And the 3 different places to connect are all fine. So you can use the R9 smart port, you can use JR Bay, or you can use the internal UART, and they all work. I say I haven't got one of the Game Boy controller, the X lights, but on the bottom. Right, so yeah, if I just move back over to the screen, you can see here on the bottom, I believe that is a smart port connector. Because you can use it to update receivers and stuff like that. In which case, that's a smart port receiver, and then you could plug the standard connection straight into that, and it will work with your X-Lite. As I say, I can't test it. I don't have one, but in theory, that should work fine. Sorry, Curry Kitten, for nicking your image, but yeah. So unfortunately, no Crossfire. Unless they update the app, I guess. But everything else is working fine. So maybe that's the last video on this, maybe not. As I say, I'm considering the Wi-Fi update. And if not, I'll probably do a video of how I stick this inside the Taranis anyway, because it's useful to have. I'm going to need something to connect to the tracker, whether it's Bluetooth or Wi-Fi. So I will need something. I'm going to make it switchable, so if you're not using it, you can switch it off, save wasting the battery. But until then, thank you guys for watching. I hope you found it useful. A like would be great. The subscribe button and the bell if you want more content. And remember to get out there and fly like you stole it, especially after all this quarantine. Take care, guys. See you on the next one.